Hi everyone, and welcome back. I hope you had a really nice break. Up next, we have Thomas telling us all about managing Python packages with Nix. I'm really excited to learn more about Nix. I've heard of it, but that's about as best as we've gotten so far. Thomas is a lapsed web developer turned contractor working in software-defined radar, like radio waves radar. That sounds cool.
Radio Arrays Radar.
Nice. An advocate of functional software design and a lover of curly boys. He's perpetually chasing the next yak to shave, dragging along all who will listen, and having a blast learning new things. And Thomas has let us know that he's happy to take questions, so please feel free to ask them in the chat, and I'll collate them, and we'll try to have time to get to them. Thank you so much. Take it away, Thomas.
Hi everyone, I'm Thomas. In another life, I used to be a web developer, and now I work in software-defined radar in the defense space. I am talking about taming your Python dependencies with Nix. So, talking about packaging, it's nobody's favorite topic of conversation. It's kind of like doing the dishes after you've had a big meal. Like, it's got to be done, but you want to spend as little time on it as you can. My first brush with packaging was as I just started university. This is my very first laptop, and I had met a group of fantastic people at the comp sci club at university, and they taught me about this awesome thing called Python. And getting into Python, I learnt about Django, which still, it changed my life. It sort of defined the first 5 years of my career, at least. One of the things that we tried to do at the time was to build a LAN management system, a forum for people who love going to LANs. And as part of that, we needed to install the Python imaging library to handle all the pictures that we wanted people to be able to upload. But at the time, there wasn't really a good way for people on Windows, specifically XP for me at the time, to get native dependencies like pill installed. It needed a whole bunch of C stuff, but the package at the time, it wanted to compile it on your computer, and I just couldn't get it working. Eventually I found the awesome people at Pythonware who provided these fantastic installers, and I was able to get these things installed, but it was just a lot harder than it needed to be, and I ended up carting around like a whole bunch of installer executables for quite a while, just in case I needed to be able to install it again. So how do Python packages actually get installed? Still today, as true as it was then, most of them get installed into site packages. If you're lucky, and you're on a Unix-like thing, that can be installed by a package manager. If you're not, you end up just installing them out of executables like I did, or running setup.py install on a zip file that you download. If you needed to run an analytics machine, which I didn't have access to at the time, you needed root to install, and no one was really going to give me root at that time. Easy installs sort of made that easier. It allowed people to get stuff from PyPy directly from the command line, and this allowed me to get a lot of stuff installed in the day. It was fantastic. It was made a lot better by Pip. Pip actually knew how to install multiple things at once, and introduced requirements files, which made it easier to install everything like in a big group, so that you could have one file that defined everything that you required, and all of their versions as well. Eventually, virtualenv came out, and that was something that I had to struggle to convince people to install, because it sort of took control of your Python package installation and separated them off into these little mini virtual mini environments where you could install a bunch of packages for just one project, and you could have mutually incompatible packages installed at the same time for different projects. It was fantastic. Python 3, I believe, builds it in with venv. Don't know how you say that. But this allowed us to separate projects, and if you had a lot of projects on the go, as I did at that time, it was really invaluable in making sure that you don't break one project that you're working on by installing something for another. These days, SciPy, Anaconda, Beware, we have these fantastic curated package sets that integrate a lot more tightly. But it sort of feels like we're moving away from that open bazaar of PyPy, where you could get anything at any time, for slightly more closed, user-friendly solutions. Oh, that's not going to show up. All right, there's supposed to be a picture there. There's a lot of issues that aren't still fully solved. We're still sort of doing incremental installations. So you install, like these package managers, they install things one after the other, and the order that you install things really has a big difference on what you actually get. So I've got this picture, took it from Daniel Wheeler's fantastic SciPy 2019 talk, which you should definitely watch. This is Anaconda building a thing called MyEnv. If you ask Anaconda to install PyPy, which is a differential equation solver, it will go and get NumPy for you, and it will build it with the BLAS MKL backend. If you then install SVPy, that also requires NumPy, and it will just use the one that's there. But if you install SVPy first, which is a finite element package, that requires NumPy, but it requests it to be built with OpenBLAS as the backend. So the order that you request it to install VPy and SVPy really determines the backend that it's actually going to use. And depending on what processor architecture you're running on, BLAS and OpenBLAS have very different performance profiles. So you can imagine if you and the developer next to you, or the scientist next to you, are trying to benchmark a piece of high performance code, and one of you's installed VPy first and the other person's installed SVPy first, you may be pulling out your hair going, why is the performance so different between our two builds? These diamond dependency graphs are, still one of those great unsolved are still unsolved in many cases, but the tooling is doing a lot better these days. You've also got the problem of native dependencies. So often when you install a package, it's the standard advice is go and install build essentials, because your package is probably this package is probably going to want to compile something or link against something. And so, if you install LXML, it's going to want to compile or link against libxml. If you want PyQt, it's going to compile, CShims to talk to Qt. PyCrypto requires, OpenSSL or a similar SSL like CryptoLib under the hood. We've solved it a little bit with wheels because they can contain shared libraries that get packaged up along with the wheel. But how do you patch wheels across many virtual invs? If there's a problem in one of your shared libraries, do you have to go and patch every single one? It would be good if there was a way that we could update that once and have all those projects benefit from that update. There's also system dependencies. Your operating system provides a lot of services and can have services running for you that you might depend upon. For instance, if you're running a web project, your tests may require ephemeral PG, like Postgres that can be set up and torn down really quickly. It might require Redis to properly test your caching layer. These kinds of dependencies aren't really well captured with the current set of tooling for Python packages. I also want to talk about reproducibility. So, in the scientific field, there's this great reproducibility crisis. A lot of papers, a lot of research is published either without code at all because it's considered proprietary, or with just a big tarball dump. And that even when you got a tarball dump of all the code, you don't really know exactly how it was built. What operating system did they build it on? What version of the package is? Did the developer who actually ran this study, did he have a patched version of that one package that worked around a bug? Are you going to hit that same bug? So there's the 10-year reproducibility challenge, and they are challenging people to get creative, pull out a paper from 10 years ago, pull out some research they did, or even just an old project from 10 years ago, and see, can I still get this to run? Is this still something that we should be able to rerun and revalidate today? And can you even do it? I also want to talk about what reproducibility isn't. Like, it's not about proving software provenance. This is something I often see brought up as a straw man. You know, that you need reproducibility to prove that the binary I got from person A is the same as the one that I would have built myself. It's not really about that. I think code signing has sort of standardized code signing has sort of made that not really an issue. But what reproducibility is about is more about operational concerns. I want to know, how can I onboard a new developer like in under a week? They shouldn't have to sit down and spend a week installing all of the different packages, all of the different dev tools. Reproducible software requires reproducible build environments, and reproducible build environments are also great development environments. And if we can reproduce them automatically, then we should just be able to load them onto a new dev's computer straight away. I also want to know, how do I containerize this thing? Unless you're shipping static binaries, you should probably package apps with a container. I don't think that that's like a contentious position to take these days. Like containerization, Snapd, Flatpak, Docker images, they're just a really great thing to have if you want to get reproducible sets of software developed and like deployed out to a lot of people. Docker files are a great start. They can have fairly surprising semantics, and they can produce fairly fat images, and so they're something that I would like to avoid. I also want to ask questions like, why can't I replicate that production bug in my development environment? Someone, probably me, patched the system libraries at some point, and I didn't notice or forgot. This is a true story. I have spent a week debugging an issue like that before. And it's very easy, even with virtual environments where you've specified it to contain system packages as well, to have an issue like this. I also want to know, how do I release my code along with my academic paper? Or maybe even not an academic paper, but like just a report to a different department. Like how can I give them something and say, oh yes, this will run for you just as well as it works for me? And will my peers be able to reproduce my results in 10 years' time? So I want to introduce you to Nix. Nix is a powerful package manager for Linux and other Unix that makes package management reliable and reproducible. Nix is kind of an overloaded word here, so we'll go through what it actually is. So Nix is a pure functional, lazy configuration language. The pure functional part makes it really easy to give it guarantees about reproducibility, because if you always give it the same inputs, it's always going to give you the same outputs. And it's lazy in that it will only build as much as you actually need. Nix, in italics, is a package manager that builds and manages environments using that Nix language. It has over 100 contributors since 2003, and it contains a Swiss Army knife of tools like Nixenv, Nixshell, Nixchannel. On top of those things is built Nix packages. This is a community-curated collection of Nix package definitions. Nix packages has over 40,000 packages, and over 3,000 of those are Python packages. These people, the volunteers have done a lot of work doing the tricky part of packaging up a lot of these packages that have traditionally been hard and relied on a lot of native libraries. It has multiple stable releases per year, and it has a very fast-moving unstable channel where you can preview a lot of changes that are going to come out. NixOS is a GNU Linux distribution configured declaratively with Nix, and it has an awesome module system that makes it simple to specify services and configuration without actually worrying about which packages that's going to require. Like, it handles that under the hood for you. Now I want to define some terms. So in Nix we talk about expressions, and expressions are pure functions that describe your desired package or package set. Their dependencies become parameters to this function, and this is fairly standard for people who work with dependency injection systems. A derivation is the result of an expression instantiated into a .div file, and that file concretely defines the build inputs and build process for a package, including all the hashes of the inputs. And it will give you a derivation that has a hash on the output. The result is the build output from following the rules given in a derivation. It contains only absolute paths of other derivations in its closure. And this is what you would typically be installing. The closure is the graph of outputs referenced by a particular result, and these are all loaded into the Nix store. And the Nix store is the graph database that all the outputs are cached into. So how do you actually go about installing Nix? Well, it's fairly simple. Depending on your tolerance for installing things curled off the internet, you can go and download this. It's a fairly simple script and you can inspect it for yourself. But if you're doing a single user installation for a development machine, you can just install it no daemon. And what that means is that when you run all the Nix tools, they will run as you. If you're in a multi-user installation, this is a machine that you want multiple people to interact with, I recommend installing it in daemon mode. That will install the Nix daemon, and the Nix daemon is actually what will build things into the store and manage the store for you, and it provides an interface to the Nix tools to be able to request things to change in the store. Enabling non-free packages, like e.g. if you want to use Chrome and the Chrome WebDriver, you need to allow unfree. That's not enabled by default. And you can just drop this line into your Nix packages config. Uninstalling is very easy. If you decide that you don't like it after giving it a try, it installs a path hook in your profile. Just get rid of that, and rmrf the Nix store. Gone easy. So Nixenv is the ad hoc package management system that comes with Nix. You can query for available packages, you can install packages, you can upgrade packages, and you can uninstall packages. Fairly standard stuff, but crucially, doing all of these things can be rolled back. They're not actually destructive operations. You can always revert. So what actually gets put into the Nix store? If we query out my Python version that I've just installed, it tells me that we're relying on all of these packages under the hood. This is the transitive closure of Python 3 on my system, and this is what I've got installed into my user profile. We can also perform package maintenance. You can update your channel, so you can pull down patches and backports for your currently active channels. 1909 and 2003 are currently active and getting backports, and Unstable is moving ahead at a great pace. I think they're going to branch for 2009 soon, and that'll be exciting. You can also roll back updates. So it's a generational garbage collected system for packages. So if you want to roll back, you just roll back to the last generation. And the last generation is the thing you had before you installed or removed that last thing. You can perform some garbage collection. So if you decide that you're not going to need to roll back to anything more than 30 days ago, you can delete older generations by a certain amount of time. You can also ask the Nix store to garbage collect any packages that might have been installed to build something, but now that thing has been built and you just want to get rid of all the sources. We can also hard link duplicate files in order to share space. So, taming snakes. Nix build is the system for building environments. You can ask Nix build to build your environment into the local store, and it will output a link that gives you a shell script that you can run, and it will activate that environment. It will put everything that you've asked it to put on your path, and give you access to those dev tools. Nix shell is very much a similar thing. It will give you a transient shell that has all those things, and in pure mode it will give you just those things and nothing else. Nix derivations, I'm running low on time so I'll go through this quickly. They're fairly simple things. Build Python package is part of the standard library of Nix packages. It gives you a very quick way of declaring packages and what their inputs and outputs are. Integrating with clibs is handled with the clibs that are already built into Nix packages. You can reference those directly through your build inputs, and it will only reference like the actual shared objects that result from those. You don't actually need to reference any of the build tools in your output. This will give you a dependency graph, and it only requires runtime dependencies. Only includes runtime dependencies, so you can actually throw away everything that you used to build it and just distribute the things that were built. For reproducibility, you can pin that package set. So if you want Nix packages like from a specific date, you can go and look that up, get a commit hash from GitHub, and you can pin your packages so that you always get exactly the same packages every time you run this script. Tooling in the ecosystem. Many other tools are included with Nix. Vim and Emacs configuration tools and plugins are part of Nix packages. You can create a completely reproducible Vim and Emacs configuration. It includes cross-compilation toolchains that don't pollute your cross-compilation targets with system headers. Makes it very, very easy for working on cross-compilation. It has Docker image creation tools. Nixery.dev is a fantastic online tool for generating Docker images on the fly from Nix packages. It also has OS image building tools if you want to build lean, bare metal OS images. Container and VM-based system test tools are great if you have distributed systems that you're building. They can provide a lot of test infrastructure for those systems. Talking about Python specifically, there's two projects I want to talk about. MacNix is a system that provides a very pip-like interface. It's also got a kick-ass logo. I love their logo. It pulls packages from either Nix packages or PyPy, either as sdist or wheels. So it gives you like a per package basis way to pick up packages that you actually want. And it's especially good for packages that have like gnarly C dependencies. You can pull those from Nix packages and pull the rest from wherever you want. The only downside is that it does have a big PyPy dependency database that you need to download, but you only need to do that once. Poetry to Nix. I absolutely love Poetry to Nix. Poetry to Nix uses Poetry, which is a fantastic Python package manager, and it just pulls in the lock file. So if you've already got a Poetry package, it'll pull in the project file and the lock file. The lock file contains all the hashes that you need anyway, and so it will produce a fully reproducible build just from that, straight into your Nix store. And that reproducible build can be shared out using any of the existing Nix tools. Lorry and Derenv. Derenv is a great tool. I think it was discussed earlier. It allows you to set up a whole bunch of environments variables based on an input. In this case, we're using Nix's MK shell to give you a shell environment, and Lorry will allow you to reload that environment whenever it changes. We can also deploy to Docker. Docker building, you can build on a Mac and it will build packages for Linux because Docker only understands Linux binaries. And you can load that image and run it just as if it was any other Linux environment. I also want to plug these fantastic resources. Nix.dev is a fantastic guide, very in-depth, a very good narrative structure for learning about Nix. The Nix manual is incredibly comprehensive and comes with a lot of fantastic examples. Nix Pills is a deep dive into Nix, the system, and like the system behind it, and yeah, have a look at these other great things, especially these other great talks by SciPy, by Daniel Wheeler and Asko. And thank you very much, and I'm happy to take any questions.
Thanks so much for that, Thomas. Unfortunately, we don't have any time for questions
Okay.
right now before the break. But just from that, it sounds like there's a lot of really great entry points into Nix. And like once you said generational garbage collected package management, like I was hooked, and I'm really excited to go try that out in some of my personal projects now. Up after the break, we have Florian Haas talking about HA Proxy and Django, and we will see you all in about 10 minutes.
Thank you.